Okay, about the notation. Okay, as I mentioned before, from the previous example, you are given, so z is the function of x, y. So in terms of notation that we can use is, you can just use z, which means that you want to say del z over del x, where you can also use del f because you also have the f means the function of, okay, x, or you can have fx, or you can have zx. All of them are the same. Okay, so just to share with you, so I don't want you to confuse when we have to use z, we have to use z, and when we need to use f. So actually they are the same. Okay, so if you are asking, you are given the function and they ask you to find the fx, so fx, find the fx at the specific point. So instead of this say in language, determine the fx at the point, okay, at the point at apa? Okay, at apa? So at 1, 2, at 1, 2. So meaning that after you differentiate, you will get the expression in terms of x and y, right? Then you have, after that you have to substitute the value of x equal to 1 and then y equal to 2, and then your final solution should be a number, a value. Okay, so instead of they put in this form, so this one can be also written to be fx at point 1, 2. So they have the same meaning. Okay. Okay, these are all the technique. Don't worry. In the exam, we will attach this list of formula. Actually, in the e-learning, I also uploaded that. Okay, I'm not sure whether you have tried to download and look on that or not, but it is already given. Okay, so now we look at the example 1. So just ignore the solution. So I give the solution just to make sure that for those who miss, who don't understand, you can refer back to the notes. So just look at the question. Okay, because I'm sure that as for now you don't really understand how can we obtain this particular expression. Okay. So the first example, we have f xy given by x cubed y plus x squared plus y squared. Okay, so now we if you look at here, we focus on the two variable first. So once we feel comfortable, you really understand about how can you differentiate the two variable function, then we can extend to three variable function because they have a similar manner, same ideology. Okay. Okay, so the first, find the del f of del f over del x. So a del f over del x, which means that you have f x. So you want to differentiate the expression in respect to x, meaning that y constant. So always bear in mind y constant. Okay, so what is the answer? Then you have to look at the term by term because you can see the summation symbol plus. So you can do the differentiation process separately. Okay, so now we look at the first term, x cubed y. Okay, look at this. Can you see the x? Can you see the x in the expression? Yes, you can see, meaning that y here is just like number 4, 10, 100, minus 1. So what happens if you differentiate that? So this one is constant. So just take note. This one is constant. This constant. So just look at the x cubed. So what happens if you differentiate the x cubed respect to x? So you will get 3 x squared and then put the y back because y constant. So that is the answer for the first term. Okay, so 3 x squared y. Okay, now look at the second term. So the second term is x squared y squared. Can you see the x? Yes, you can see x. So meaning that it is cannot be 0 because you can see the x here. Y constant. So y constant. So y squared here, they are all constant. So you just disturb the x squared. So what happens if you differentiate the x squared respect to x? So you will get 2x and then just copy the y squared because y squared is constant. So that is your second term. 2x y squared. So that is your answer. So what do you think? Simple or still confused? Okay, look at the second one, B. So the second Fy, del F, del Y. So you have Fy. Okay, so Fy. Again, you have to look at one by one. Okay, the first one. So the first, we have x cubed y. Oh, because you want to differentiate with respect to y, so x constant. X constant. Okay, remember that? X constant. So can you see y here in this expression? Yes, meaning that the answer cannot be 0. Okay, because the constant is just x. So x cubed is a constant. So we don't change that. So this is x cubed. So now you ask yourself, what happens if we differentiate y with respect to y? So you will get just x cubed. So you just have x cubed. Okay? And then we go to the second term. You have x squared, y squared. Can you see the y? Yes, you can. Here. So meaning that after you differentiate, the answer cannot be 0. So x constant. Please remember, you are working on y now. So x constant. So x constant means this value are constant. X squared is constant. So now ask yourself what happens if you differentiate y squared with respect to y. So you will get 2y x squared. Okay, then plus 2y x squared. So that is your answer. So you got this one. Okay, so the third one, C. So you have to substitute a value there, meaning that you have to use the result of Fy. Fy when x is 1 and y is minus 1. So where is your Fy? So Fy is this one. And then you plug in the x is 1. So y 1 cube plus 2 minus 1 square. And this will give you 1 minus 2. So you will get minus 1. Minus 1. Oh yeah. Okay, I have to check first why the answer is different. 1 minus, supposed to be minus 1, right? I think that's correct. Okay, so the answer is supposed to be minus 1. So just double check again. 1 cube 1 and 2 multiplied by 1 is 2 and minus 1, so minus 2. So 1 minus 2 is minus 1. So there is typo there. Okay. And another example. Okay, so now we want to look at the other example. So just numbering example 2. So A, we have f again is the function of xy. X cubed y square x squared y. Now we have a longer expression for x plus 5xy minus 5y. Okay, x cubed y, x cubed y square, x squared y, 4x, 5xy minus. Okay, so we have to find both fx and fy. Okay, so we work on the fx, differentiate respect to x. Okay, now we have to look one by one. Okay, the first one. Now differentiate respect to x. Y constant. So can you see the x? Yes. So y constant. So you just differentiate the x cubed. So you will get 3x squared y squared. Okay, now we move to the second term, plus. Can you see the x? Yes, so meaning that you cannot give me 0, so it should be an expression. And then you can see y is constant, so we just differentiate x squared. So you have 2xy. The third one, can you see x? Yes, but no y, right? So when you differentiate for x, you will just get 4. And the fourth, can you see the x? Yes. So y constant. So what happens if you differentiate 5x? So you will get 5, right? So 5y. Can you see the x here? No. So meaning this one all constant. So differentiate constant, you will get 0. So that is your answer. Okay, just checking. So 3x squared y squared, 2xy, 4. Okay. Now we go to the second one. Fy. Fy. Differentiate respect to y, x constant. Remember now, x constant. So can you see the first? Can you see the y? Yes. So the answer cannot be 0. Now just differentiate the y squared. So you have 2y. So 2y x cubed. X cubed does not change because that is constant. Okay. Plus. Now look at the second term. X constant. So now x squared constant. So you just have y, differentiate y, you will get 1. So you have x squared. Okay, move to the third. Can you see y? No. So for x, these are all constant. So what happens if you differentiate? You will get 0. The fourth, can you see the y? Yes. So y here, just y. So what happens if you differentiate? Just this y becomes 1, so you have 5x. So can you see y? Yes. So just y here, differentiate y, you can see, you can have 1, so you have minus 5. So you will get 2y x cubed plus x squared plus 5x minus 5. Okay, and look at the b. B we have a bit more complicated. So you have 2y4, now sine of x. Now you have a multiplication here between two functions, plus 7ex minus 6ey. Okay, now we want to work on fx. Differentiate respect to x, y constant. Okay, look at the first term. So you have the multiplication of two functions of y4 and sine x. So you want to differentiate respect to x. So where you can see the x here? Inside the sine only, right? Only the sine x. So meaning that the function of 2y4 is a constant. So in this case, you don't need to apply the product rule. When you need to apply the product rule, if you have, let's say, 2x4 sine of x. So you have x, your x is inside both function. You have inside the sine and you also have x inside the power of 4 function. So for this, if you want to differentiate with respect to x, then you have to apply the product rule. Do you remember what is product rule mean? Which means that the formula u v prime plus v u prime. Okay, but in this case, the x is only inside the sine, but not in the y4, the function of y4. So 2y4, it is a constant. So your answer is, you just copy 2y4 because it is a constant. So you just differentiate the sine of x. So you will get cos x. Okay, So we're done for the first term. And look at the second term. So can you see? Yeah, of course you can see the x here, just single x. So what happens if you differentiate the exponential function? So you will get the same. So you just copy. Okay, and then for the third term, can you see the x here? No. So meaning that all 6 EY, these are all, the outcome is constant. So what happens if you differentiate constant? So the answer is 0. So you just have 2y4 cos x plus 7ex. Okay, now we look at the fy. Okay, now back to the f again, the expression again. So again, now we are looking for y and x constant. So where can you see the y? Only in the power of 4 function. And sin x here is constant. So for sin x, because it is constant, so you just copy sin x. And you differentiate to y4. Differentiate with respect to y. So 8y cubed. Okay, so that is for the first term. Okay, now we look at the second term. We want to differentiate the function, the expression here 7ex with respect to y. Can you see the y here? No, meaning that these are all constants. So meaning that when you differentiate with respect to y, it is 0. Okay, now we look at the third. You can only see the y. So what happens if you differentiate the ey? So you will get the ey back. So you will have negative 6 ey. So your answer is 8y cubed sin x minus 6y. Okay. So the next is so this question is from another book, but I'm not sure which book. Okay, so I leave this for you to do an exercise. I mean, just part of the activity. So which means that you have to complete this, and I want you to post the answer in the Padlet by using the link of Q&A that I share with you. Oh no, I will create a new one because that one is a combination of the section 33 and the section okay, but that's fine. So can you can just use the Q&A Padlet. Okay. So post your answer. So I will please put your full name on the Padlet so that I know who is the owner. So easy for me to just jot down. Okay. Okay, so this one I skip this because as you can see, yeah, the answer is given. So if you don't understand, so please let me know. Okay, so I think you have no problem with this. Okay, because the process is just like the same that I show you from the previous example. Okay, so the exercise only this one. Yeah, so please post on the Padlet. Okay, that I shared the link in the Q&A. And of course, you can see that in the e-learning as well. Okay, for the Q&A. Alright, so that is just a direct differentiation without using any specific method, which is technique. For example, chain rule, what else? Product rule, quotient rule, and so on. So now we have, we want to see how and when we can apply that specific rule or method. Okay, so we look at this example. Example 5. Okay, the function is 2x squared y plus 3 xy square multiplied by, okay, E5 of 5 multiplied by xy. And then you have to find fx at the point of 1, 1. So you need to get that. So before that, you have to provide the fx first. Okay, so now, look at here. You have the only single term, which means that you have just a single term which there is a multiplication of whatever in the bracket and the function of the exponential function. So in this case, you need to apply the chain rule. Okay, so you have to take note that you want to differentiate with respect to x. So y always constant. Okay, so in order to differentiate this, you have to apply the product rule where you have to assume this is u and this is v. Okay, so u is 2x squared y plus 3xy squared. Okay, since you want to differentiate with respect to x only, so you have to put the ux, meaning that you want to differentiate the u over the x. Okay, so now back to we got two terms here. So you have to differentiate with respect to x, y constant. So look at this term. So y constant, y here. So you just have to x squared. So when you differentiate, you will get 4x and then y. Okay, and followed by the second term, y constant. So you just only have 3x. So you differentiate to x, you will get 3. So 3y squared. Okay, and then your v is e to the power of 5xy. Okay, then here you need to provide the vx because you want to differentiate. The formula is u vx plus vu x. So the prime here you replace by the x because we only want to differentiate with respect to x. Okay, so in this case, this is there is a function in a function. The outer function is exponential function and the inner function is the fxy. So here you need to apply the chain rule. Okay, remember chain rule? When you have a composite function, then you have to apply the chain rule. What does that mean? What the meaning of the composite function? There is a function in a function. Okay, so the outer function e fxy. Okay, so differentiate the outer function, you will get the same e 5xy multiplied by the derivative of the inner function. Okay, so now we want to focus on 5xy. You want to differentiate the inner function, right? Which means just 5xy with respect to x. So now you can see the x here. So your constant, your y is constant. So what happens if you differentiate 5x with respect to x? So you just have 5y. So that is how you apply the chain rule. Different what is chain rule is the name, the procedure. But then what is the step that you have to show on the paper? So it is the derivative of the outer function, because this is exponent, you will get the exponent back, multiplied by the derivative of the inner. So you just, with respect to x, so you just have 5y. So that is your vx. Okay, and then then back to the question, you want to obtain the fx. So the formula is u vx plus v u x. So then you just substitute u. So u multiplied by vx plus v multiplied by ux. Okay, so that is the expression that you can obtain after you substitute all the expression. Okay. So since you have to compute, so meaning that you don't need to simplify. Okay, because the final answer is a number, so just you don't need to simplify. I mean, if they said that, so normally you can just leave your answer in this form. Okay, but if you can see that this one can be simplify, then you have to, but it looks like we can just leave the answer maybe, or maybe you can expand. Yeah, you need to expand and then factorize the 5x, where we can have this one. Okay, but in this case, because in this case they're asking for the substitution for specific x and y, then there is no need to put the simplified form. Okay, so now replacing the value of x11, xy11, so you have 2 plus 3, then multiplied by 5, e5 plus e5, 4 plus 3. So you have 25 e5 plus 7 e5 will give you 25, 7, 32 e5. Okay, you can leave your answer in this form, e5. You don't need to compute. Okay, so we have another example where we will look at on the next video.